Hi Harsha, hi Jitender. Are you able to hear me clearly? Is my screen visible? Great, great. So, should we start or do you have any questions before we start? Do you have any questions for me? Harsha and Jitender? All right. All right. So, I assume that you don't have any questions. Did you try to run these examples which we did in the class? Harsha is saying, I'm planning to learn MapReduce in depth. Is it necessary? Because I'm No, it's not necessary to learn MapReduce in depth. Whatever is required, we will discuss it during the session. Okay? Whatever is required, we will discuss it during the session. All right? Because MapReduce has got its own details, while Spark has got its own details. Although the conceptually MapReduce does apply to Spark, but the details are different, right? Make sense to you? All right, Jitendra, do you have any questions before we start? Gaurav? Gaurav, do you have any questions for me? All right, let's then jump in. Okay, so I hope you must have tried this particular example where we were trying to multiply a huge array by 2. Okay, so this multiplication would happen over multiple machine. Also, even though we have demonstrated here that one element in one machine, but in reality there will be multiple elements in on a machine. Okay, So this is called a partition. Partition means a single machine, okay? Part of RDD that is loaded on a single machine. So every big RDD, big data set has got many partitions, okay? Each partition is on different machines. There are some operations which are specific to partitions. There are some operations which are very specific to partitions. We will consider them at later point of time. All right? Good, good. Moving ahead. All right. So far we saw that we took an array. This is basically an array of a million elements, and then we loaded it onto the cluster by saying parallelize. We say sc dot parallelize means convert this array into RDD, and then we created a function called multiply by 2, and then we executed that function on the RDD which we had created. Okay, we executed that function on nums, which is our RDD, and once that was done, we took first five elements out of it. Now, this first five element is something interesting. This is an action. And if you noticed, while we did everything from here till here, nothing much happened. Nothing much happened. The actual work started when we said take. The actual work started when we said take. All right? You must have noticed it yesterday. All right? Let's log in. Also, those who are finding it difficult to copy paste, you can try Control Shift V here and it should paste on Windows. And Control C means copying the data. For me, it works fine on Mac. For you, you can try, if you're on Windows, you can try Control C and for copying and Control Shift V for pasting it. Okay? You can try and let me know if it is working or not. All right. All right. Now, so let's try to execute this a little bit and then see if it is working fine. You can use the browser-based terminal. I'll be using my this SSH terminal. I'll be more comfortable. Okay. Bin dot PySpark. Bin slash PySpark. All right. So here is multiply by 2. Okay. And if you notice that it's doing everything, like it's not exactly doing anything, it's just making notes that that ARR means it's a range and nums is equal to this. It's not actually doing anything, it's just taking notes, it's just defining the meaning of ARR, it's defining what is nums. It's just defining what's a function. It's just defining what is DBLS. And at a later point of time, the moment when we say things like take, okay? When we say things like take means we want to take the five elements out of this RDD. If you try to check what exactly DBLS means, it says that it's a Python RDD. Okay? To take out the data, to bring the data back to you, okay, from the cluster, you need to say take. Now, the moment we said take, it started the whole process. It started the whole process parallelly. Okay? So you can see that it's a DAG scheduler. We will also discuss what does it mean by DAG. If you have heard about directed acyclic graph, it will be good. Basically, when we are defining these things, it's making notes. It's creating a graph saying DBLS depends upon nums and nums depends upon ARR. So the moment we say DBLS, then it goes back and till here, okay, and then it recomputes everything. The moment we say take, it first loads the data. Parallelization has already happened, so it basically applies this function on the nums, and then it takes those elements out. All right. So these kind of functions called take are called actions. These actions bring back the data from the driver to these functions bring the data from the RDD to the driver. Driver right now is us who are executing this command from the terminal. All right. Any questions at this point? An action causes the full execution of transformations. It involves both Spark driver as well as the nodes. Okay, all the nodes which are participating in the RDD will be involved in an action. All right. So as we just told you that dbls.take is what is an action. So action does two things. Action for brings the data from the RDD to your local machine. You can think of it as opposite of sc.parallelize, right? It is kind of an opposite because sc.parallelize takes data from your local machines, distributes it on the cluster in the form of RDD. Okay? So this diagram shows you that an action is basically bringing the data back to the cluster, back to the driver. Driver, it could be your program, which might be running inside any of the application master, or it might be running on the same machine from which you launched the process. All right. Now, so there are, all right. So that was a quick example of action. And let me get into more transformations. We will keep on going back and forth between various transformations and action. So do not worry about the sequence much. I'll take care of the sequence. So we defined a basic transformation. We defined basic example of action. Let me try to explain more transformations. Okay. So the first transformation was map, where we took an element from each node and converted that into, we took each element and converted it into something else, right? Multiplied it by 2. So that was a transformation called map. Map basically make your function run on each node and let it create a new RDD by transforming the existing one. Okay, so that was the map function. The filter function is interesting. It creates another RDD from one RDD by picking the element, by choosing the element. And on what basis do you choose the element? That is defined by the function which you are passing to the filter. For example, we have got this huge range of values, right? We have got this huge range of values. Let's try to do this. So we have this nice range. Now, next thing we are doing is we are saying sc.parallelize. We are loading this data onto the RDD. Next is that we are going to create a function called isEven. Okay, let's check if isEven is working. Is even for 3 is false, is even for 1 is false, is even for 0 is true. So is even is working fine. It's a normal Python function. Okay, what we have done is we have divided by 2 and compare the remainder with 0. If it is 0, that means it's even, otherwise it's odd. Alright, now let's try to apply filter. What filter will do, it will let all the elements of num go into evens. Evens is another RDD which will be prepared as a result of this filter. So all the elements of num will go to even if they return true for is even. So every element, say 1, will be passed to. Okay, so let me just try to, yeah. So something of this sort. This something of this sort will happen inside. Okay. Similarly, here 5 is being passed. All right. Okay. So when is even is called on 1, it returns false and is not put into the RDD. While when 2 returns true, it is put into the RDD called evens. Similarly, when when 3 is called, it is returning false, so it's not kept in output. So this is what filter does. So you can make anything filter. You can make the RDD smaller. Let's say if you only had to pick up the years which are what do you call those years? Leap years. Okay, you remember what did it mean by leap years? All right, let me answer Ishwar's question after this. All right, so you can see that when the action is happening, so we are taking our function called isEven and running it against every element. Okay, running it against our is even function is being run against every element, and in case is even returns true, uh, then in case is even returns true, then the value is put in the output. Okay, output as in the another RDT. This is another RDT, and out of this, when we say take, out of this, the elements will be brought back to your console. Okay, although this RDD looks smaller, it's actually there are many more elements here. There are many more elements here. You can say dot 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 dot. Okay, so there are many more elements in this second RDD also. It's only for the demonstration purposes we have kept three elements. Alright. Now, when you say take on this, then it will bring it back to your node while the data is distributed across the cluster. Alright. Now, there is a question from Ishwar that generally in big data we bring code to the data. Good. Let me just increase the font and say Spark. All right. Here it's different. No, no. Okay. So what's happening here is this data is lying on the whole cluster, and this is your code, right? This is your code called is even function. And when we say nums dot filter and pass this function, what's happening is this function will be taken to all the node in the network, and on each node is even will be executed on on multiple elements. Okay, one element at a time. On every element there will be hundreds of values, and against that it will be executed. All right, is that clear, Iswar? Yes, only the result is sent back to the driver manager. That's correct. And the how do we gather that result? By saying take. When we say take, then we bring the. So do not say take 100, okay? Because then 100 there will be a transfer of data from the RDD to your node. Okay, so generally you do not bring the whole data back to the node, or you do not bring too much of data back to the node. First you finish churning everything over the cluster, and only then you execute an action to bring it back to your node. All right, is everyone with me? What's actually happening? So this filter gets executed across the cluster. I mean, filter executes our function is even on every element which is loaded in the cluster. While when we say take, it brings data back to your node. Howsoever elements, how many elements you mention here, those many elements will be bring back to you. Okay, great. Now there is another map. So as I was telling you that the 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 total kinds of functions which are applicable on RDD are vaguely categorized into two buckets. One is called transformation, other is called an action. So far we have only seen one action called take. We have seen two transformations so far. One is map, other is filter. Okay. Now third transformation which is provided by an RDD is called flat map. Okay, so in case of map function, our functions which we handed over to map, they created only one element. Okay, so there was a one-to-one relationship between one RDD to another RDD. You could see this in here. When we say map, one element led to one another element. That was map. Now what if your function is giving out more elements? Something like, let's say you want to convert an RDD in which there is a each element is a sentence. This RDD called lines contains by default, when we load the text file from the HDFS, the file by default contains lines, line 1 and line 2, right? And when we want to convert it into words, which means we are trying to convert one element of RDD into multiple elements of RDD. To do so, you will you will call a method called flatMap on your lines RDD and pass the function which converts this string into an array. Okay, so your two words function here is converting each line into words by calling split. By default, the split function on in Python breaks the line by spaces. Okay, it breaks the line by spaces. All right, let's try to jump in. All right, so I'm going to say sc.parallelize. Okay, now two words. So two words is a function which I'm creating, and I have loaded the data. This data is quite small for here. Okay, we'll take bigger example at a later point of time. We are converting this array which contains lines, sentences as each element. So it has got two elements right now. This lines RDD has got only two elements, and we want to convert this into one word per element, something like this. Okay, so what we do is first we write a function called two words. Let's check if two words is working fine. Okay, this is a cow, for example. I'm just testing my function right now. I'm not interacting. Whenever I'm testing it, I'm not, you know. Okay, so we have a mistake here. We just caught our mistake. Good. So this kind of testing is really useful for for finding your mistakes. Okay. Now let's try to do again. Let's try to execute this function we call two words, which takes a line in argument and by splits it by spaces. Okay, so you can see that it has converted our string into an array. Okay, we can try to say check whether it's an array or not. Okay, you can further try to say, all right, and you can also check the length of this array. Sounds good? So our function is working fine. This function is working fine. Now is the time to run this function. Now is the time to run this function over the cluster. So what we do, we take our RDD, which represents the lines over the cluster, and execute a function called flatMap, passing the definition or passing our code. This is our code. Okay, so we are telling Spark that here is our code, please take it and run against every element in the RDD, and whatever gets collected form another RDD out of the results. Okay, out of whatever has been collected. All right, now you can see that in we could use take 10 here. You see that? So it got us all the elements back to the node. Again, here we loaded all the values into our RDD, created a function which breaks each element or each line into words, passed that function to flatmap. Flatmap converted our values into one word per element, and then we said collect. Here I said take 10. You could also say collect. So collect is another action. All right. Collect is another action. And diagrammatically, this is what is happening. So flat map two words is breaking our word into multiple elements, breaking our line into multiple elements. Is it clear to everyone? All right. Ishwar, Gaurav, Harsha, Jitender, Mehndi. Is it clear to you? Great. All right. So that was our flat map. Flat map converted one element into multiple. So if I ask you a quick question to all of you is, in Hadoop MapReduce, if you remember, okay, the map was equivalent to Spark's A map or B flat map. Even if you don't remember, it's okay. All right. Anyone? That's correct. It is flat map. Great, great Mehndi, great Ishwar, great Gaurav. So yes, it is flat map. Why? Because because in in MapReduce, flat map in Spark returns multiple keys, as was the map of Hadoop's MapReduce. All right. So in case of our Spark's map, we were just returning one value. We're just translating one array into another. Great. Moving ahead. So you must notice that map was equivalent of Python's map, right? Now there are other transformations which transform the RDD but do not bring the data, do not give any results. The other transformation is union. Union basically concatenates two RDDs together, okay? And then you can perform various kinds of operation on those elements. So for example, we have as A equals to SC dot parallelize and B equals to SC dot parallelize. Now A is this. If I say collect, collect also brings data back to the node. Collect is another action, and B dot collect, right? So it's bringing data back to it. Okay. So A contains 1, 2, 3, B contains A, B, C. If we want to create another RDD, which is a concatenation of the two, we can use union and we can say C dot collect. See that? Okay. You see that? So C dot collect basically showed us that this RDD called C was having all the elements together. Okay, sounds easy to you? All right. This is how you can visualize the union. Okay. Let's say we had error logs file called input RDD. Okay. Out of that, we filtered the error and we filtered the warnings. If we say union and we want to bring all the bad lines together, we can use union here. Union of error RDD dot union warnings. Okay. So if you want to bring the lines of A before lines of B, you say A dot union B. If it doesn't matter and you basically are trying to say B dot union A, that's also completely okay. All right. There is not much of a difference. Okay. So we could see that there is a kind of RDD lineage graph during the analysis of logs. We are trying to analyze the logs. First, we filtered the logs for errors and warnings, and rest of it we have ignored. And then we said union, which will basically join the two data sets and bring us bad lines. Okay, it's not joining; it's just concatenating. If you are coming from databases background, you will understand that. Also, note that it might look like it might look like union is a set operation, but it's not really a set operation. Okay, why? Because if there are duplicate elements in 1, 2, 3 as well as ABC, then they will not be removed. Okay, sounds good. The another action which we have used is collect. Collect brings the data back to the cluster here. All right. Do you have any questions for me here? So when we load the data into the RDD, we can say A dot equals to this, and then we can collect the data back. This becomes, the moment you say collect, it becomes your local array. Okay. So I'll show you this. So let's say we loaded the data, we're pretty happy with this, and then we said local array equals to a dot collect. And if you notice, the moment we said local array equals to a dot collect, then everything started happening. Now you can check what is inside the local array. This is your Python array now. It's no longer an RDD. It's a Python array over which you can iterate. Say for x in local array, and you can say print, say what you want to do, print x print x into print x into 10, for example. All right. So we have basically we are able to iterate through these objects very quickly. Now you can go ahead and again create another array based on sc dot parallelize. So you can create another RDD based on your local array. Local array is just a name I've given. You can say it anything you want. Okay. Now this has become an RDD. All right. So basically, what dot parallelize does, a dot this collect does opposite of that. Sc dot parallelize takes your local array. This is your local array. Okay. While collect brings the data back from RDD to the local node. The difference between take and collect, take take gives you only few elements. Okay, so take always in the form of take n. Okay, gives you only those many elements, while collect is in the form of this. Collect gives you all elements. All right. Now a question from Gaurav is this true? As union runs on multiple nodes, so ordering may be anything in RDD. So when we say union, and union is going to parallelly convert one RDD into another. Okay, so it makes sure that the ordering is intact. Okay, ordering is kept intact. All right, because it's not much of a set based operation. Had it been a set operation, then we would expect it to keep any order. All right. It always keeps a same order. It basically takes first data and append the second data. That's it. All right. Any questions at this point? Am I running too fast? Harsha, Jitender, Mehdi, Gaurav, and Ishwar. Am I running too fast, or are you comfortable? Ishwar's question is, what if the union's result overflow the memory? Okay, so if this is going to overflow the memory, then it generally would give you an error. Okay, it generally would give you an error. Although our although there is a way although there is a way to convert the data into persistent, as in you can save this memory based data into disk, and then there will be no fear of consuming too much of memory. Okay, we'll discuss those parts. Good questions. All right, so everybody is comfortable with the speed. Mehdi is comfortable. All right, good. Rest are not comfortable with the speed, except for Mehdi. All right, all right. So Gaurav is saying that I'm going a little fast. All right, thank you for letting me know. All right, so I can slow down, no issues. All right, I can slow down a little bit. So if you have any questions at this point of time, we so far have discussed a few things. We started with flat map, a new transformation called we started with new transformation called flat map and filter. Also we discussed what is an action, and then we went ahead with union, and then we went ahead with the another example of union, and then we collected the data using collect method, and that's another action. All right, take we have already discussed. So take is something where we can bring only few elements from the cluster to the local node. All right. So for example, when we say this is our RDD which we have loaded just now, and sc.parallelize basically takes your local array, puts it into the cluster. So and in the form of RDD. RDD is okay. So this resilience distributed data set, you can bring four elements out of it to the local array. Okay, or if you just so it's like saying head. There is a command called head in Unix which brings the first few lines of the file and prints it to you. Okay, comfortable? Good. Now sometimes you just have to count number of elements. Okay, now so far we had been trying to show that there are there are multiple one element per node or something like that, but that was not the case. Okay, ideally ideally if there are three machines in the network, or you can say there are three partitions of your data, if there are three partitions of your data, then you can basically there are three partitions of data. Your array might be located like this: some elements in first partition, some elements in second, some element in third. And when you say count, what exactly is going on? This Spark driver application is asking every partitions for their counts, okay, and then summing it up. The same thing is happening everywhere. When we say take, it's asking the various partitions to give us the data. All right. And also, if you want to if you want to explicitly say there are these many partitions in your RDD, you can say that. Okay. All right. So we have just done, we have brought back the number of counts here. All right. So so count might look straightforward, but internally it's basically talking to every partition of your RDD. Your data set has got many partitions, and you can also explicitly define the partitions by saying this. Okay. So a dot count is talking to all the partitions, asking every partition for their number of elements, and then summing it and giving you the result back. So Gaurav's question is, here is a question from Gaurav. Take 4 will process all the records first in RDD, or it will stop so it will stop the moment it gets 4 records. Okay, it's a sequential operation. It will go from one partition to another. So first it'll go to first partition, try to get, say say 4 elements, but it only got 3. Then it will get those elements and then go to the second partition. Then it'll pick up the fourth element and then it will stop the process. Good question. All right, sounds good to you? All right, so there is a question from Ishwar. Let's say I want to have a sample of 5 elements from all the nodes. Okay, so there is a function called sample. We will discuss it, and we will go into the that detail also. All right, no worries. Good. So there is a what do you call, a transformation called sample which we can use, and after sample we can collect. All right. So we talked about the basic transformations and basic actions. Okay. So we talked about count, we talked about collect, and we talked about map, filter. So so far the transformations which we have come across are, first was map, flat map, filter, right? And actions which we have come across so far: take, collect, collect, take, collect, and count. Good. These are the actions which we have talked about. All right. So while we talked about executing an action, we observed that the things are happening only at the action. Whenever we say take and count, then it takes a little bit of time. Only when we say take, collect, or count, it takes a little bit of time. Otherwise, it doesn't take time. It just returns quickly. So what does it mean is that whenever we are executing an action like take, collect, and count, it is basically doing something. It's doing whatever we had declared earlier. This is called lazy evaluation. It's evaluating lazily. Only when only when you are calling an action, the transformations on which this action depends upon get executed. All the transformation on which an action depends upon, they get executed. Okay. So let's say we are loading a text file, filtering it, then calling map. Nothing will happen. These will not get executed until you say count. The moment you say count, then the whole process will start happening. It will first filter, then will map, and then will give the results. Okay. So this is called lazy evaluation. Okay. So when we call transformation, it nothing is evaluated. Okay, it is not evaluated immediately. It helps. And why is it so? Why is there a lazy evaluation? The objective of lazy evaluation is to make sure that Spark can optimize things. Why? Because say there are something happening in filter and something happening in map. So Spark can figure out that there are two transformations happening. So can it execute, combine the logic of filter and map together and send those filter and map to the nodes and get it executed on individual nodes and get the results. Instead of doing first translate data from one filter to transfer the data because of the filter and then again transfer the data because of the map. So it tries to optimize a lot. It tries to optimize a lot. All right. Let me try to put it again. Let's say you are saying sc dot parallelize and there is an array you're creating from 1 to 1000 elements. Now, as part of B, which B is let's say equal to A dot map, okay, we are just multiplying all the elements lamp lambda x x into 2. Okay, we are multiplying all the elements. I'm just using, instead of creating a function, I'm using inline function. If you have an objection with this, I will create a fresh function. Okay, is it, if it's not clear, I'll make a fresh function. Then we are creating C, which is again saying b dot map, and we are saying lambda x. So after multiplying, we are adding 1 to it. Okay. So we are basically trying to compute x square plus 1. All the elements sorry, x into 2 plus 1. So all the elements should be multiplied by 2 and then added by 1. Now at D, we might be trying to do things like a dot filter, and we are saying again lambda x, and we could say x percentage 2 equals to 1. Now if you notice here, all these things are an operation on this data, right? This data gets multiplied by 2, then plus added 1, and then checked whether it is odd or not. Okay. Now, the moment we say d dot collect, we are expecting to bring all the data which is qualifying, which has been transformed because of these transformations, right? So it would make sense to get it done together, both the maps and the filter. If it is done together, it will be faster, right? Because there'll be minimal amount of transfer of data involved in case of these transformations, because they're applying on, it's basically chain of things. All right, so you do not have to, ideally if I had to optimize this code myself, I will write all of this in a single filter, right? In the filter itself, I will first multiply it by 2, add by 1, and divide by 2 and compute whether should I filter it or not. Okay, I'll do everything inside the filter rather than the map. Okay, but you do not have to worry about it the, because Spark will take care of it. The moment you say collect, it will first compute on which D depends. So it found that okay, D depends on C, C depends on B, B depends on A, and these all the things are looking like transformation. So let's merge all of them. Okay, so those kind of optimization, those tricky optimizations are done by Spark for you. All right, does it make sense to you? So how will these optimization happen? Is it clear to you? So if you have used pig earlier, pig Latin, there also the moment we say dump some data set or store some data set, the whole process used to happen in the same spirit. There also we were trying to optimize a lot. So instead of thinking an RDD as a data set, think of it as an instruction on how to compute data. That's also a better way of thinking. Okay. So if you are, you can always think of an RDD as if it's a statement which will get executed at later point of time. Make sense to you? Yeah. So is it clear that how will it optimize this internally? All right. So out of this, okay. So out of these three, the moment we said d dot collect, only then the action is happening. This is called lazy evaluation. We are evaluating B, C, and D lazily. We are not evaluating them immediately. We as in Spark. All right. So the same thing, internally, what it will do is the moment you say d dot collect, it will figure out that okay, there are three transformations which can be combined together, and effectively, what it will do is it will create a fresh filter where it will say x into 2 plus 1 divide by this, and will delete both this. Okay, so it combined these three steps into one. Okay, so that you can get the same data. All right, correct. So till the collect is called, it will store the definitions. Okay, it will not compute anything. So data set is basically each data set is nothing but a statement. The real process happens when we called an action. Make sense? It's like creating views. Okay, it is like creating views. So when you say select star from view, whatever query because of view are there, those queries will get executed. So view is not really data, so it's like a view in the database speak. All right, moving ahead. So same process has been depicted here. Let's say we are trying to clean up a text file. We loaded the data from the file. Lines 1 is after executing map 1. Lines 2 is after executing some map 2. Okay. And dump lines. What is map? Map first is cleaning up is stripping the new line, and second map is converting it to uppercase. So the moment we say dump, instead of calling dump, I will say collect. Okay. I'm confusing it with our pig. All right. The moment we say collect, what would happen is that it will execute these map 1 and map 2 together on the same machine instead of transferring the data. Had it executed them separately, then what would happen is that data will get transmitted twice. Clear? Now is this clear? The lazy evaluation and optimization? Everyone? Mehndi, Jitender, Harsha, Gaurav, Ishwar. Ishwar is okay. Gaurav is okay. Mehndi is also okay. Brilliant. All right. So if you have any questions, feel free to ask all the time because the objective of these sessions is to get your questions answered before you get blacked out. Okay. Otherwise, you'll just blacked out and think that, okay, I did not understand previous topic, so I will not be able to get it. All right. Sounds good. All right. So again, as usual with any programming language, we are going a little backward and forward. So the function passing in Python is in this form. Okay. There are two ways of creating functions in Python. The second one, which we have been using for quite some time, and the first one is in the form of lambda function. Lambda functions are anonymous functions. Okay. Lambda functions are anonymous functions. So here we are saying, so a lambda function always has a single statement. It returns the value. All right. So a lambda s is a function which is translating, which is returning whether the keyword called error is there in s or not. Okay. So for each s, it's trying to return true or false if that error keyword is existing in that string. Okay. The same thing could be written as separate method called def contains error and return error in s. So this statement and this statement both are exactly identical. All right. So whenever we say something like this in lambda, whatever is here before the colon becomes the argument, and whatever is here becomes here saying return. So that is lambda function in Python. Lambda is a very important term in the whole computing. Lambda was the way the recursion was formed. Lambda is kind of came before recursion came into programming. Okay. There's a lot of, it's a part of mathematics concepts. A lambda, they call it lambda algebra or something like that. Okay. That's why everywhere you'll see lambda. So lambda in our term is a anonymous function which returns, always return a statement. Okay. Define the function. I hope everybody is clear. We say def function name and use that. All right. So whenever we are launching a function and we are sending our code, we are handing over, we are basically handing over our code to Spark. If we are doing that frequently enough, we can either choose to write an inline function called lambda function, or we can define a proper function. My personal choice is a proper function. Reason being, we can reuse a proper function, we can reuse this, but we cannot reuse this. Okay, because if you created this, it is nameless function, it doesn't have any name to it, right? But if you have multiple RDDs and their filters, so you can always say RDD.filter contains error, RDD2.filter contains error, and so on. But this one, you'll have to copy the whole statement. If you have to modify this lambda, then you everywhere the same syntax is being used, you have to use that one. Okay, so if your function is really small, then you can use lambda. Otherwise, consider using a proper function. All right. Now there are few things you have to notice if you are coding a lot in Python and you are calling the filter from inside of any of the objects, and you are passing the bigger objects. Okay, say for example you are calling the filter on self.query, self.match, and so on, or you are passing basically any of the argument which belongs to a object. Okay, so what would happen is that you will end up sending too much data to the RDD. You would end up sending really huge function object to the RDD. So you have to be very cautious while calling the while while calling a transformation or a action on Spark. While calling any of this, and you if you have to pass a function or an object, be careful. Do not send too big an object, because it hurts the performance. If the object is too big, again executing that object is going to take enormous amount of memory, and also it is going to consume more amount of time to deserialize and execute it. Okay, forming the function again would take time. Second is, so what would you do instead is, instead of passing self query dot in, pass a proper class, a very trimmed down version of it. And how can you trim it down? Remove all the references to an external object by dereferencing them. So if you say query equals to self dot query, then query is just a string, not an object, and then you can send it like this. All right. Or you might choose to just send the self, okay, as an object, and we will do think about it later point of time, which may not be a great idea. All right, is it clear the mistake which can occur? Yeah. All right, is it clear to everyone? All right, Ishwar says okay, no worries, let me repeat it. All right, that was all right. So if you notice here, if you are from Java background, it is equivalent of saying we are passing this here. Okay, so what is X here is the element, and we are applying some part of self.query. Now, the moment Python notices it, what it will do is it will send this full object. You see, it's a big class which is called search functions, and it has got the argument here. Now, it has got a constructor, it has got isMatch function, other function, and so on, right? Now, if you try to call self.query from within your lambda function, which is an anonymous function, what will happen is this whole object will be sent to all the nodes. It will be sent to all the nodes where the filtering will execute this function and try to get the results. Why it would do so? Why would it send it to all the nodes? Because it is thinking that you want to use this full self object, because that's what you are referring to here. Okay, self is equivalent of this. Okay, self means this object. So here what exactly is happening is I'm saying rdt.filter lambda x colon self dot query in x, right? Which means lambda needs to know what does it mean by self, right? Self means this object, which means this whole object would be needed while executing this particular function. While executing this particular function, this whole object would be required. That's what lambda would say. Okay, and thereby, when we are saying rdt.filter, this whole object gets transferred to all the nodes, all the partitions, and then it will get executed. Okay, self means this object. So whenever in our Python code, whenever we want to refer to the object in which the function is being called, we use a keyword called self. All right, does it make sense, Ishwar, now? So the self is equivalent of this in Java, and this means reference to the current object. All right, everybody. So instead of this, you should clean your call to the filter function. You should not have reference to the bigger objected. Instead, you should just have only those objects which are required for your purpose. You can simply say query equals to self.query because that's the only thing you want. You don't want the full object, right? And thereby you make sure that not to overload your Python, not to overload your RDD. Yes. So there is a point from Gaurav. Let me. So in Java, we pass object itself, but in Spark, to avoid deserialization multiple times, we should pass value only. In Python also, we will pass object sometimes. When we find that passing object is less heavy, we will do that. Okay. All right. Because what happens is these objects are in-memory objects, so they are going to consume RAM. So be aware if you are sending too much of work. Imagine this: there were five more objects, and you by mistake are calling those objects. So you would end up having five, six objects consuming the memory. Okay, and that would happen on all over the cluster. So your effective consumption of memory will become n number of times because there are n number of nodes. So on every node, the instance of these objects will be recreated and will be, and then your filter objects will be used. Filter function will be used. All right. Sounds good. And in Scala is a similar language like C. I mean, it's somewhere between Java and Python, Java or C++, you can say. So it's somewhere between Java and Python. So the function passing looks like this in Scala. You first, if you have a class in Scala, you can basically create function in the similar manner. Okay, you can define function, and then this is the argument called RDD, where it's a string of this particular, it is a particular class having this string and so on. Okay, and there also you have to make sure that you copy the query to a separate variable, and then you call the function like map. Okay, all right. So the way you pass the functions in Java is this. So this was Python. This is Scala, where we are trying to pass, where we are trying to, there also we are having lambda functions. Okay, and this is a way we are calling edge match function on the RDD. So this is normal way. We are defining a function and calling it. Second way is by creating lambda function. This is a lambda function in Scala, and where we are saying that argument to the function is x, and after this equals greater than sign, the whole, it is the whole body of the function which is returning this expression. So it returns x dot split, whatever argument is given to it, it splits it by this particular keyword. All right. So Gaurav is asking that which is preferred language in Java, Python, or Scala. Okay, so it's a difficult call. It's a difficult call, and almost everything could be done in Java as well as in Python as well as in Scala. Okay, but there are few functions that are only available in Scala. Rest of the functions are available in Python. Okay, so if, I mean, we will go over Scala quickly at later point of time when we think that it's required. Okay. There are certain APIs which are not available as Python, for which you might have to use Scala, and we will go over Scala quickly for that. Right? All right. So it's very difficult to actually. All right. So here are a few points. Although this debate can go for quite some time, but yeah, let me try to go through your points. So Gaurav is saying that which is preferred language in is Scala, Java, Python, or Scala for development and production, or can we develop a POC application in Python and then use Java for actual project product? All right. Now, what Ishwar is saying, that there should be a benchmark, and that would help you make the choice. That's a good point. I'll come back to Gaurav's point after this. All right. So yes, on an average, on an average, Python code is a bit slow. Okay, but it can be compiled to make it fast with things like PyPy. You could compile your code and which will run like Java or C. All right. So you can get everything done using Python and on Spark, and also you can run it really fast. All right. But if you try to run your Python program by default, they'll be a little slower. But slower doesn't matter. Okay. But slower doesn't matter because it doesn't matter in case of handling volume of data. But if you are handling, but in case of stream processing, you may not prefer Python. Okay, so you can say that Python is slower than Scala, which is slower than kind of Java, because at the end of day, Spark is written in Java. And because if you remember our discussion, that Spark runs on top of virtual machine, which is in application master, which is in Yarn, and which is written in Java. And similarly, the internals of Spark are written in Java, but it lets you alter most of the behavior using Scala. Okay, so therefore the order of things is Python, Scala, and Java when it comes to the execution. Okay, but development cost is inverse. Python has got, and so is the development cost. Okay, so this is the performance. So given all of these constraints, I found that doing it in Python makes more sense, because when it comes for performance, we can anyway execute things using PyPy, and that will be efficient enough, right? All right, does it make sense to you, Gaurav and Ishwar? All right. If you are creating RDD from one programming language, you can access the same RDD in another programming language. Okay, keep that in mind. Let's take a break. Thank you, Ishwar. So 10 minutes break. All right. Is everyone back? Can we start now? Mandy, Jitendra, Harsha, Gaurav, Ishwar. So, using Java, you could also pass the functions. There are three ways of doing so in Java. Okay. First is creating. I think I will go with. Okay. First is by creating the anonymous inner class. Let's take the second one. Second one is by creating a class which which implements a particular interface and then overriding a method called call. So whatever you write while overriding a method called call is the one that contains the logic. So the general syntax is you will create your own class my class implements some a, a class called function, a interface called function, and then you define that okay, we are concretizing this as in our function will be returning boolean and will accept the argument as string. Okay, so we are telling about our function, we are telling the the details about our function. Okay, so if our function is operating on our RDD which contains string, then we mention here string and also here string, and while returning from the function we will mention whatever we want to return. Okay, so our actual code is only this much from here to here. We are saying whatever string is being passed to it, we will find whether it contains error or not. If it contains error, it would return true. Otherwise, it would return false. So this is how we create a function which can be sent to all the nodes. Okay, this is how you hand over the function to another method which will execute that function at its own will. Okay, it is like creating various kinds of handlers. If you have been from the UI kind of background, there we generally create the event handlers and we hand over these event handlers to to something like button dot click. When button dot click happen, then your function will get executed. So your function, you hand over the logic of your handler to button dot click, and button dot click will execute it whenever it wants to do so. In the same manner, you created a function, you created a class and handed over that class, the instance of that class to filter method. It will execute your method, it will execute your class whenever it wants to. Okay, it wouldn't it will run it on the RDD and give the results. So this is a classic way of handing it's a classic way of handing over the logic or handing over your code to another function so that that function can execute your logic at its own will. All right, so this is a classic way of executing things in Java, but since it's too much of things every time, it becomes a little bit of a headache. Sometimes if your logic is smaller, you might want to create anonymous inner class. Okay, anonymous inner class by saying everything else is exactly same, just that from here to here has been copied in the anonymous class, saying new function. We are basically extending, implementing this particular base interface, and then providing the meaning of, providing the implementation of call method. So that's how we pass the anonymous inner class to Java. All right. Third is by passing something called lambda function. Luckily, Java also came along and said that we will also provide lambda function for anonymous inner methods. So just like other Python and Scala, they have also started providing lambda function after Java 8. Okay, so if you are having Java 8 on your cluster, if your cluster is running Spark, there are high chances that it will have the Java 8. Okay, so you can start using lambda function. If your cluster does not have Java 8, do not use the lambda expressions. So Iswar Krishna's question is, function is in which package? Okay, all right, so I'll show you this. Did you try to execute this Java code? Any of you? Did you try to create a project? Those who are interested in Java can use this. Okay, so you can see this here in the imports. Everything is available. Okay, so it is in the, okay. Try running this and you'll have a clarity. All right, and the library which you need to have is available in your lib folder. I have brought it to the local file system from my lib folder. If you have a look here, I'll show you. So here ls lib, you'll see this particular one. You can use this in your Eclipse project. Okay, not this one, Spark assembly, this one. All right, this is the jar which you need to include in your Eclipse. All right, in order to get it executed. If you are from Java background, then you'll be more comfortable with that. All right, let me exit Eclipse. So here we are very simply saying for s as an argument in our anonymous function, our function will return s dot contains this error. So it's the most simple way of defining this. Now, one question from Gaurav is, I think he has got the answer, but I'll still repeat. So is Spark, which runs on Yarn, supports Java 8? So it supports everything, and it has been running fine since quite lower version of Java. Okay, so yeah. But if you are using lambda expression, make sure you have Java 8 in the production, otherwise it will give errors. All right. So this was a little digression where we went ahead and we went through various kinds of ways of declaring functions. So in simply in case of Java, we can do it in three ways using lambda expression, named function, or inner classes. In case of Scala, you could also do it in the same way, lambda expression, and external functions. In case of Python also, you can do it in lambda expression or external function. Okay, a proper declaration. All right. There are many more transformations and actions which are there in Spark as opposed to our MapReduce paradigm in Hadoop, where there was only map and reduce. Here there are many more functions to facilitate the computation. Okay, so the next, you know, the next transformation, the next transformation is, let me just mention it. So next transformation, which is quite useful when dealing with statistics, and I think Iswar was also asking about the same thing, is sample. If we have numbers, if we have say some objects and we want to randomly pick some objects out of it, you can use sample function. Okay, so the sample function takes two arguments. First is replacement. Should we replace the things once we are done, or should we not do that? Okay. And second argument is the fraction of total amount of records. So if it has got 100 records and we say 10, zero point 0.1, on an average we will get 10 records. Okay, although it you might get less number of records like the way you are seeing here we have got only 8 records. Okay, so approximately zero point 0.1 fraction you will get out of it. Let's try to do this. Okay, if you have console ready, you can also try with me. Okay, okay, so we have created an RDD out of 1 to 100. All right, we can now say sample equals to sequence, which is an RDD dot sample, and we can provide, we are saying here don't replace the item, which means there should be no duplicates in the output, and we are saying zero point 0.1, which is the total fraction of the records. Now once we are done with that, we can say sample dot collect. Okay, you can see that we got these many records this time. Every time Okay, so we, when we executed sample dot collect, we got this. So my question to everyone is, will two executions result in two different data sets? So if I execute sample.collect again, will I get same result or different result? I'm just calling collect. I'm calling an action which will bring the data from RDD back to my console. So if I execute sample.collect again, will I get this result or will I get some other result? Same result or different? Gaurav says they may give different results. Ishwar says no. Okay. So no as in different or same? So Ishwar is saying I got the same result. Let's try to see this. Okay. So this is what we are getting. Wow, this is opposed to the theory. Interesting. Ideally, we should have got different results. Let's just say, ideally, we should have gotten different results. I think, interesting. All right, I need to understand this part. Either there is something wrong with sample that is giving the different results, same results. Ideally, it should have given different results. Sample.collect, sample.collect. Yeah. I think it's retaining the seed of sample every time we are calling that. Okay, and when we call sample.collect, it basically uses the seed. Okay, because sampling will happen every time. This is something different these people have done. All right, let me have a look at it. Why did it? All right, never mind. Theoretically, yes, Harsha and Gaurav. I was expecting. Right, right. So what is this guy doing is every time we say sample, it generates a seed. So seed is a common terminology when we talk about random number generation. So seed is what decides that what will the random number be different or the same. Okay. So generally people keep timestamp as seed, and in case the sample is marking it with a seed, then maybe that is the reason. All right. Right. All right. Okay, so next part is the true part, as in saying that we can replace as in we can put that element back, meaning we are letting it select it again. In those cases, there might be duplicates in the output. Okay, so we could chain everything in a single shot. If I have to chain everything in a single shot, I can chain it. Say for example, if I have to say sc dot parallelize and then sample and collect. So here all three things, parallelize, sample and collect, are all chained together. Okay, you can see in a single shot I got the result. Okay, now I'll keep on getting different results. All right. Also, there could be a chance of repetition because we are saying allow the replacement of the items. All right, see, this time we have got repetition. This time we have got enough repetitions. Correct. Yeah. So if you run like this, that's what Ishwar is saying. If you run like this, then you get different results. If you run like the way, ideally, theoretically also, every time we say collect, the whole DAG is evaluated because of the lazy evaluation, right? The whole process should repeat, and hence sampling should have resulted in different output. Probably the sampling was being is retaining the seed, and that is why sample.collect, even though it's executing everything again, it's okay, it's giving the same result. Yeah, so this will give different results. Yeah, that's correct. All right, good. Moving ahead, any questions at this point? Feel free to ask questions here. All right. All right. Now, sometimes what we want to do is we want to do certain computation only on the partition. We want to only run maps on individual partition. So, for example, let's say we have this, okay, and we have basically converted it into we have converted this array into an RDD, and we are saying here that we want two partitions. The second argument in parallelize says that we want that many partitions. Okay, so this array has broken down into two parts internally, and if you want to just sum up the partitions, we can do things like this. We could say define my function, and then okay, define my function and then sum all the values. Okay, we can also say something more meaningful like this. Okay, yield and return are the same thing. We could say return as well, it's similar thing. Okay, we could say things like this. Okay, now after that is done, we could say rdd dot map partition and then collect. So after mapping we are just saying collect. All right, what happened? Yeah, you have to say yield in this case. All right. So basically, what we got is 3 and 7. It has divided our data into two parts. Okay. 1 and 2 and 3 and 4. Okay. So we could also do things like, in case of here in this function, we could concatenate the values instead of summing them. All right. So if we had to, concatenate our values, what will I do? We will say this dot join. All right. Let's try to first test it and then see if it is working or not. So if I run my function and say, so it has generated an iterator and looks like working fine. Let's try to do this. So we are, instead of summing up, I'm just concatenating them by colon. It's saying, all right, I will have to find another ways. So string equals blank, and then for value in vals, string equals to plus equals to, converting integer into string and then yielding the string. All right. What is wrong with this? So I'm defining my function, creating a string, that way. Yep. So good. Now let's try to execute this with our data. String object is not callable. What does it mean? Uh, all right. Why it's called type string? Yeah, this is better. All right. Yeah, this is good now. Now you see that 1 and 2 have combined together, and so are 3 and 4. We could, let me again put that code here. We could also define another function which would, all right. All right. We could also define another function like this. All right. All right. Let me explain what have I done. So the overall objective of this exercise was to be able to concatenate the values or do some operation only on one partition. As we have told you earlier also, that an RDD is divided into partitions, and each partition can have one or more elements. So here we have divided our partition, our array into two partitions on RDD. One is containing one partition containing 1 and 2, second partition containing 3 and 4. And in the previous example, we computed the summation of only the partitions. Okay, only the partition. That's why we got 3 and 7. And how do we do that? We create our function just like the way we did it for map or other functions. Similarly, we create functions here. This function will get an iterator, and using that iterator you can do various kinds of operation. In this first example we have computed summation. In the second example we went over the values and concatenated them. Okay, so you can see that 1 and 2, 1 is concatenated with 2, but this bunch is not concatenated with other bunch. All right, sounds good to you? This is map partitions, basically when we want to do operations within a partition. The 10th question is why would we, so his question is why. Do you mean to ask is why would it be required? Jitendra? Okay. So do you mean to say why did we not receive this too? Because this two is not part of our array. This two means we want to divide our array into two sections. If we say 3 here, the results will be very different. Okay, results will be very different. Now you can see it has become 1 2 and 3, 1 2 and 3, 1 2 and 3 4. All right. So Gaurav's question is, what is the use of partitions? Shouldn't Spark maintain the partitions? Yes, it does maintain the partition. It's an extra functionality provided to you. Sometimes you want to do such operation which will finish within the partition, and these operations within the partitions are very efficient. Okay, because they don't involve transfer of the data too much. Generally, you would not bother, but sometimes if you just want to operate on a partition, it makes sense. And why did I bring map partitions here is just to make you feel or believe that yes, the data set is being partitioned. Yes, you can say that it's like a combiner in MR because combiner happens on part of the data. That's very good analogy. Thank you. All right. Okay. So there is one more question from Jitendra. Let me just repeat what he's saying. His question is, what f iterator do? What we pass to, what we need to pass to f? We don't need to pass anything to f. Okay. Here, any iterable, as in iterable, any array is good candidate for map. So this f, if we have to call it by ourselves, we will be passing an array of elements. Okay. So in here, if we want to call this function ourselves, we will be calling it like this. Okay, and it will return us something called a generator. If you are from Java background, it will return you like a cursor. Okay, it's like a cursor. Or you are from RDBMS background, then also you can understand. Cursor is something which will keep on giving out the value while you are reading from it. Okay, make sense to you, Jitendra? Great. Now Ishwar's question is, what is the logic of splitting to the partitioning? Can we define that? All right. So yeah, there are various libraries, and you can also create your own library on how to split or partition the data. The general strategy can be defined by the library. All right. We will also go through that at a later point of time. Sometimes you might want to load your JSON object. Sometimes you want to load the data from RDBMS. Sometimes you might want to load the data from HBase or HDFS or from in memory. So this strategy is generally, defined in those libraries in conjunction with our parallelize method. Okay. So here what it has done simply is 4 divided by 1. 4 divided by 3 is 1. Therefore, first elements got 1, 1, and the remainder has gone in the last one. Okay? Alright? Good, good. Did I miss anybody's questions? All right. Now, sometimes you want to order your data. Sometimes you just want to order your data. In those cases, you can use a function called sort by. Okay? Sort by can sort your data quickly. All right? Let's try to create a function where we are trying to sort the data. Let's do a little different thing. Here, let's say we want to sort our numbers by their ASCII value in a lexical manner, the way the things are stored in dictionary. All right. So let's say we want to do that, and so we can say things like my RDD equals to SC dot parallelize. Okay. 1 comma 2 comma 3 comma 4 comma 5. All right. So this is our RDD which we have loaded from here. Next is we want to sort it. We can say sort by. Okay. Now when we talk about sort by, we can provide the function, our sorting function. Okay. Our sorting function. What does this sorting function do? So we can define our sorting function. Okay. Which will give the basis on which the things will get sorted. So here, whatever is being passed to us, we will convert that into a string, and that's it. Okay, we will just return that as a string, and the rest will be taken care of by the Spark. Okay, so let's try to do this and collect also here. All right. It says invalid syntax. This is good. It's the issue of oh, there was a new line actually in that. All right. So this sorting function is just converting whatever we are giving, it converting into a string. All right. Now nothing much of a difference. Now see the magic. Now if we say 10 and 2, 3, and we also put somewhere 21, now you'll see the magic here. All right. And we say rdd dot sort by. Now do you see the difference? 10 came before, then 2, then 21, then 3, 4, 5. Alright? Why? Because we have converted these into strings, and if we order strings, the 10 comes before 2 in lexical order. Okay? Is this clear to everyone? Or in other words, if we have to kind of uh, order them in decreasing manner, we could also do things like return minus of s. Okay, return minus of s. Now see, first 21, then 10, then 5, then 4, and then 3, then 2. Now it's numerically reverse. Okay, so you can utilize this sorting function which can help you sort the data. Sounds good? All right, I'm just keeping it here for other people also so that we don't miss it. All right. So there are various kinds of pseudo set operations provided by Spark or RDD to you. Okay. Spark provides you these pseudo set functions such as distinct, unique, intersection, subtract. Okay. And I'm calling them pseudo because I'm calling them pseudo because they are not really sets. Because RDD cannot be guaranteed to be a set. You might end up having too many values. You might put more values, duplicate values in a RDD, right? RDD doesn't stop you from doing that. And therefore, sometimes when you're doing intersection, you will have these values which are duplicate. So you have to make sure by yourself to do the distinct before you start doing the set based operations. Okay, these are the set operations such as intersect, subtract, union, all right, and distinct. So you have to Gaurav's question is what kind of comments are possible in this thing. One is using triple there. Triple, I'll show you my code and then you'll have. So if you are using Sublime, he is using Sublime. So I've opened Sublime is a good text editor. So this is how you can create. You can have the comments. Do you see that? And you can also have this kind of comment, multiple line comments. Okay. These are multi-line comments with triple single quotes. And with single line comments start with hash. Sounds good? All right. Any questions at this point of time? All right. So there are these multiple functions. First one is distinct. Distinct gives you the set property to your RDD. Okay. If you remember our definition of our sets, the definition of our sets was that in a set there will be distinct values, there will be no repeated values. Okay, so if you run distinct on an RDD, it will convert it into set. I mean, it will create another RDD because RDD is itself immutable. So it will give you a new RDD. All right. Second is union. Union basically appends one RDD with another. Intersection finds the common values in RDDs. removes duplicates. Okay, and also when you are running intersection, since it has to find common values, it has to search through the whole thing, it shuffles, it orders your data, it orders the data and requires shuffling, and therefore intersection is slow as compared to union and distinct. Also, while union, the result might contain duplicates because it simply appends one with another. Fourth one is subtract. If you want to find out all the values which are not there in the second subset, we can subtract second subset from our RDD. Okay, so that's what is the I mean, these are the basic set based operations. All right. The one operation which is similar to our set operations is Cartesian product. We can do a Cartesian product of one RDD with another. What does it mean? Let's say first RDD contains user 1, user 2, user 3, and then the second RDD contains Beta Brand and Asha Tea House and Ritual, and you can do a Cartesian and you will get all combinations of all of these. Okay, you can see that Cartesian product means all the values from first RDD and combined with all the values from second RDD. If you have three values in first RDD and three values in second, the total number of values in the resulting RDD will be 9. 3 into 3. All right. Questions for all of you. So if you are, is everybody ready for the questions? Gaurav, Ishwar, Jitender. All right. All right. What will be the output of B dot collect? A equals to SC dot parallelize, and then we give the array A, B, 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 C, and B dot distinct. B equals to A dot distinct and B dot collect. What will be the result? All right. Ishwar, Gaurav, Mehndi, Jitender, Harsha. Great. The answer will be ABC. Quite straightforward. Now let's move ahead. So, all right, let's move ahead. So we have got A as this and B as this. B is equal to A dot distinct and C is equal to A1 dot intersection B. What will be the result? Quickly. Yes. We are looking for intersection, Harsha. We are not unioning them. Great, great. So yes, it will be A only. All right, next one. A equals to parallelize AABC and B is a distinct of A and A1 is A and D while D is equal to B dot subtract A. B, B which is this, subtract A1. B. All right. All right. Anyone else other than Gaurav? All right. Great. Great, Harsha. All right. Good. Good. Yes, that's correct. So the answer will be C and B. All right. So this is what? This is A, B, and C. When I say subtract from this A and D, so A will get subtracted and we'll be left with B and C. Correct? Jitendra, it's okay now? Good. Good. Great. Now, next is what will be the result of this one? Anyone? Now, this time we are doing union. Union of B and A1. This is easy. Sorry, union of A and A1, not B and B. Union of A and B1. Union of A and A1. All right. This time only Harsa is correct so far. So A and A1, when we do union, what will be the result? Remember, it was simply a concatenation. It will not try to do the set based union. Okay, let's try to see if I am correct or wrong. See, see this? That's good. Good, Harsha. All right, great. Now one more question. I think this is the last one. No, there are two more. What will be the result of this one? Quickly. V dot collect is, that's correct, Harsha. Good. Keep going. Anybody else? Good. Good, Gaurav. So this time we are concatenating B with A1. Jitendra and Ishwar. We are concatenating B with A1. So B was distinct of A, which is ABC, and followed by A and D. That's correct, Jitendra. Good. All right. Sounds good to you, Ishwar? All right. Now, the next question to you is what will be the result of this? Okay. So we have got noun, which is boy and girl. Adjective is good and boy, good and bad. So if you do the Cartesian product of adjective with noun, what will be the result? Anyone? Yeah. Uh, Jiten, we are trying to do Cartesian. I think you thought it's union. Cartesian is a cross product. All right. Good, Ishwar. Good. Good, Harsha. No, it will be, the answer will be like this. Okay. For each good, good will be combined with boy and girl. So good boy, good girl. And bad will be combined with boy and girl. This will be the result. All right. Sounds good to you? All right. So almost everyone, I think everyone has got the set based operations. All right. Now let's talk about little bit more about actions. We have only talked about count, and we have only talked about the take and collect. Take, collect, count is what we have talked about so far when we talked about actions, right? Now let's talk about little bit more about actions. There are some very good actions such as reduce. Reduce is exactly like the way we did in case of Python. So Spark's reduce is same as any other mm, reduce of any functional programming language. Okay, what does it mean? It means that the function which is a reduce, the function which we are giving to the reduce function, so reduce accepts function as the argument, meaning we are handing over a function to the reduce and it will run it all the over all the elements to reach to a single value. Okay, so for example, we want to sum all the values from 1 to 100. Okay, so we will define a function called sum which takes two argument x and y, or any, well, you can give any names to them. So we'll take two arguments and we'll return the sum. Now we'll hand over this function to reduce. Now once we hand over and ask reduce to execute our function and give us the reduced value, what it does in the background is it takes two values at a time from this list of values and keep on running this function again and again and again and again till it reaches a single value. In all, it will execute this sum function, it will execute our function 100 times. If there are 100 elements, it will execute it 100 times. Okay, let's try to see what happens. All right, so we are saying this. Okay, return x plus y. Let's we will also test what happens in case of sum. All right, so here we have total as 4950. So it says that the sum of all the values from 1 to 999, 1 to 99 is 4950. Sounds good. All right. So, do you remember our discussion on reduce function when we were discussing Python? That how it took two values at a time and combined it till it reached one value? Same thing is happening here. Exactly same thing is happening. Walk you through a very simple example. Let's say we had these lines, okay? We had these lines and we are loading lines into RDD and are computing the line lengths. Okay, so the line length of this one is 11, 9, 4, 14, 20, and 4. Okay, sum of line lengths is how much? Sum of line lengths is how much? So we can see the sum of these line lengths is this much. So this is good. This is good. This is very simple. We loaded on a single machine this array and found the length of these lines. Now imagine this, that it is loaded on three nodes in parallel. First node contains first partition, second node contains second partition, third node contains third partition. So what's happening on first node? When we when we say when we say when we run our map, uh, map to compute the line length, when we try to compute line length on node 1, it gives us 11, 9, and 4, the total length. Again, when we sum up the total length, it will give us 20 and 4, which means 24. On node number 2, there is only one line there which is having 14th length. The total length is 14. On node number 3, there are two elements, 20 and 4, and the total length is 24. All right? Should I draw something for you? Okay. So imagine this. The length here is, in the first partition we have 1194. Okay. This is our first partition. This is our second partition. Okay. And this is our third partition. And we are trying to compute the total length by using the sum function. Okay, so the sum will be applied on these two values first, and how much is that? 20. Correct. The same sum function we are applying everywhere. Now the same sum function will again be applied between 20 and 4. Okay, same sum function will be applied between 20 and 4. That means it will become 24. All right. This is happening. This is happening on individual nodes. So most of the summations finished on individual nodes, inside individual partitions. Now the summation of across the nodes will start. Okay, same reduce function, just that it's getting executed on the values which are being okay, which are being brought from different nodes. Okay, and let's try to sum it here. What is the result? 62. All right. Yeah, 62. So did was I able to explain? The total is a local variable. That's a very good question. Total is when I run this particular example here, when I run this particular example here, the total is a local variable, meaning and any action when it returns a value, it's always a local value. Okay, it's a local value, it's not an RDD. It's only the transformation that returns an RDD. Yes, that's correct. The other question from Harsa is that when you use A equals to RDD dot filter, in that case, A is an RDD. Yes. Good. So is this dynamics clear? We are trying to compute total sum of all the lengths of all the strings. So what would actually happen that we try to demonstrate? So first, from the strings, let's say there was this RDD, okay? There was this RDD from which another RDD was created. This is another RDD containing three partitions. These are three partitions. Say this is one partition, this is another partition. Same partition is also applicable to the second RDD because they will try to have a similar RDD, similar sections behavior. Okay, so similar partition behavior. So let's say there was this, and okay, so in the first transformation from here to here, or I'm not able to draw it really nicely. Yeah, all right. So there was this RDD which contains the strings, meaning lines, from which we computed in each partition the length of each line. And now, once that was done, we are trying to compute the total of the line lengths. Okay, by using a single method called sum. So first, this operation up to here, these operations will finish on the same node. Once those operations have finished, it's like combiner happening here, and then these values are brought back here. All right, good, sounds good to you? All right, that is how we compute the reduce, okay, by recursively summing up the value. So action is not only bringing the data to the node, it's also doing the computation. Now, there is another function called fold, which is exactly like reduce, just that you can provide an initial value for each partition. Okay, so instead of starting with any other value, it will start with the 0 value. Sometimes while reducing values, you might want to start with a particular value. In those cases, fold will be a good idea. So in the fold, you can provide two things. One is the initial one. Second is the function. This is the 0 value and this is the function. Okay. So fold takes an initial value against which all the values will be summed up. Okay. So this is the initial value. So, and with the initial value, other values will be concatenated or summed up, howsoever you want to do, and then the values will be saved. Next is aggregate. Aggregate is also like reduce function. The only difference is that you can provide two different kind of operation for values inside a partition and values outside the partition. So you can provide two functions. One is for sequence operation and other is called combination operation. Meaning, so let's say there was this RDD containing three partitions. First partition containing 1, 2, 3, second partition containing 4 and 5, and third partition containing 6 and 7. So 1, 2, 3 can be combined together with will be combined together using sequence operation. 4 and 5 will be combined together using sequence operation, two values at a time. And here also sequence operation, two values at a time. While all the values coming from these will be combined together using combiner operation. So if we need two different functions to do this job, we can use combination operation. Okay, and that's how it will work. All right. All right, next is this is an example of aggregate where I have tried to aggregate concatenate the value on the same partition first with colon, and the concatenated value on various partitions. I wanted to concatenate all the partitions by semicolon. So that's what I've done here. Okay, you can try these examples. These will be quite useful. Sometimes you want to prepare the histogram, as in you want to count the distinct values like word count. If you want to do, you can use count by value. Okay, so you can use count by value to do the word count very quickly. All right, you can simply say here this dictionary is not an RDD, it's a local variable. Please keep in mind that all of the actions will result in the local node. Okay, and there will be an error if this dictionary could not fit in the memory of the driver. All right, sometimes you want to order the elements and get the top n elements out of it. You can say top 10. It'll give you top n elements out of your array. All right, so for example, I said top 10, so it gave me 10 elements ordered automatically. Okay, in decreasing order. More than sort by, this will be quite useful to you. All right, next is take ordered. That's also an action. If you want to take the elements in increasing order, okay, then you can use take ordered. As well as you can also provide the key, just like the way we defined earlier for sort by. You can define the key for sorting and it will return you in that manner. So we have provided a key in which it's taking x equals to minus x and it's giving us decreasing order. We have provided a string as the key. Then it's giving us the values in sorted by lexically. 1 1 1 0 2 3 4 5, right? Take sample is equivalent of saying sample and then collect. Okay, okay, so it can basically give you the sample of this data set. All right, you can try this. All right, you can see that it has given us the sample of the data. All right, let's discuss it on the next session. There are a few more things to discuss in this. We will have continue from here in the next session. All right. All right then. Thank you, Jitender. Thank you, Mehdi. Thank you, Gaurav. Thank you, Harsha. Thank you, Ishwar. Have a great week ahead. We will continue from here in the next session. Bye bye. All right. Ishwar, I'll update the notes. No worries. All right. Bye bye. Thank you very much. Have a great week ahead.